Welcome to your 2:30 talk with a clumsy talk title. Just to introduce myself, my name is Thomas Bennett and my colleague Martin Slabber. We're from a small outfit in Cape Town called Tsolo, and this is not my first time at a Ceph conference, but it's certainly my first time representing my own company. We started out in the South African Red Astronomy Observatory. And yeah, so we've left the observatory and we started our own company now. If you want to know more about the company, I've got some the contact details at the end of the talk. So why am I here standing in front of you talking? You could look at the cynical view, and the cynical view is that by submitting a talk, I didn't have to pay the conference fee, so that's pretty cool. If you look at the deterministic answer to that question, it's well, I got in a plane and I flew 11,000 kilometers to be here. So, but perhaps more interesting is the pragmatic kind of answer to that question, which is, you know, we're doing something a little bit that we think is slightly interesting with Ceph. It's not really a standard use case for Ceph. And what a better opportunity but to come and, you know, talk to people, meet the Radar Gateway guys, have some really good discussions, make sure we're on the right track, and basically keep us sane. And also just try and find if there's any opportunities for collaboration or anyone else trying to do similar things. So just to kind of clarify the talk title, I say the talk title is very, very clumsy. And, you know, you can see I haven't been to a conference in 4 years because, you know, when we decided on the talk title, I think Martin and I had a few arguments about what it should be. But anyway, I decided to put that down. But basically, we're not talking about caching here. We're talking about using Ceph as an interface. So if you kind of rebrand this entire title, we just want to do Amazon Glacier. That's basically what we end up doing. Something similar to Amazon Glacier. And that's kind of all packaged into something called Tsolo Blue, which is the nice little label at the bottom there. That's just kind of like our branding for what this product is. It's got nothing to do with Blue Store. This is something completely different. Okay, so just an overview of what I'm going to be talking about. I just broke it down to a few kind of broad ideas. There's the client. So the client is old Paymaster, the South African Red Astronomy Observatory, and I'll be talking a bit about what they do and why we think there was a future for this idea of this project that we wanted to do with them. Then the concept. So this is kind of, you know, our design process when we started spitballing ideas about how we wanted to solve this problem. We knew we wanted to use Ceph, but, you know, how do we what are the bits of Ceph that we use? How do we put it all together to end up with something that was going to be a product that we could then package into and sell onto Soreo. In fact, this is it's more of a collaboration with Soreo. They are funding us to do the research to end up with a product that they will be the first customer for. Then we'll just, as part of that concept, I'll just do a quick demo as well. So I thought it would be really fun, do a live demo, but bad idea, because obviously, like everything that could possibly go wrong went wrong. I had some network issues, and you know, my Docker containers were falling over. But I rebooted my laptop. Everything seems to be working. So if you want to do my demo, I can show you something. It's our kind of our integration, our full integration test. So that's obviously we fake a few things and we Dockerize everything, and so it's just a nice end-to-end test that I can show you, kind of, which will hopefully also highlight some of the bits and pieces, I say, of the concept, the core concepts that we kind of walked away with and decided to try and see what we could do to kind of make this Amazon Glacier kind of thing. I'll then hand over to my colleague Martin, and he'll talk a bit about the implementation. So that's the actual hardware and the software architecture of the final product that we're going to be building. We'll talk a bit about the future, you know, what do we think are the problems, and, you know, and also at that point, I'd like to open up to the floor and say, listen, you know, we decided to do this thing. This is the way we're deciding to do it. You know, are we missing something? Is this a good idea or is this a terrible idea? Because obviously, we want to kind of, you know, have an honest conversation about what we're trying to achieve. So the client, the South African Red Astronomy Observatory. So Soreo are the custodians of the Meerkat Radio Telescope, which is a telescope that sits out in the Karoo, 64 dishes. It uses interferometry to synthesize a large dish. Radio astronomy fills a very obscure corner of the science field, so not many people know about the science. But basically, there's the Meerkat project and the SKA project, which is kind of like the the national inheritor of Meerkat. The Meerkat program has run for a couple of years now, 3 or 4 years. It'll continue running for a good number of years until the dishes are absorbed into the SKA project to build an even bigger, more powerful, more sensitive radio telescope. So Meerkat currently today is the most sensitive radio telescope in the world. And here by sensitive, I don't mean it's got a brittle ego. By sensitive, I mean that it's very sensitive to radio intensity in the sky. So these are, and it's always cool to show these pictures because they look just insane. They're false color pictures. These are radio waves, the intensity of radio waves that we've observed by looking at particular parts of the sky. These images came from the Galactic Center project that we ran as kind of like a first light project. There was a really good peer-reviewed paper that came out of that. So this is an important project for infrastructure in South Africa, and and so that's why we feel the data that's being created there is this needs to be curated and maintained and preserved. If you look at papers, it's produced 190 papers, peer-reviewed papers, which mention the Meerkat data. And of that, half of that was probably done over the last 12 months. So you can see there's although I say it's this obscure part of science, there's a really great reaction from the community. So we want to make sure that we, continue being able to serve this data to the community. So kind of looking at this a slightly different point of view, which is maybe of more interest to the community here, is that how much data are we talking about? And radio astronomy data is by default quite large, and this is why the SKA project is of particular interest to people, because it generates lots of data. And you can see here for the last 3.5 years we've accumulated about 18 petabytes of data on the Meerkat telescope. Looking towards the future, we'll probably get anywhere between 6 and 20 petabytes. That depends on what happens in the next while. There's an extension program to build out even more dishes, and once those are included, the data rate actually increases with the square of the number of dishes. So every dish you add, you're squaring the data problem. So it's as you add more dishes, this problem gets quite. That's why it's like 16 to 20. And we as I said before, the idea is that we want to preserve this data for a long time. Radio astronomers typically take a long time to work through the data. These are big data sets, so we want to make sure that data remains there. So now it's like unpacking this, understanding the requirements, and luckily we came from the observatory. We understand the data sets quite well. These big data sets are read in. The scientists only have some interest for a short while, where they download the data, process it, and create new data sets. But then at some point, because there's so much data coming in, they lose interest in that and they move on to the next piece of data. However, sometime later, an interest will grow again about a particular data set because they've found something interesting and they want to go and review the old data that was captured. So you can see that there's a facility in keeping this data and keeping it for a good long while. And so, it's what's quite nice is this is a very simple client. There's one tenant, although there are a number of institutions internationally that access the data, there's still one source of data. It's the telescope. So it's actually quite an easy model to kind of understand and get your head around in terms of what we need to support, in terms of making sure that that we make the data easily accessible, but at the same time we allow for kind of an expanded view of what data is and how you access it and how you store it. So now onto the concept. This is my clumsy title. So once again, this is not a caching layer really. This is just an interface. So we use we decided we want to use this as an interface, and kind of this evolved from. Let me just take one step back here. So obviously, I love my my little Baldrick quote here. As there are a lot of companies out there doing S3 to tape, and that's what we're trying to do, S3 to tape. There's Amazon Glacier, there's Spectralogic, have Black Pearl. But what we think is important is, as a community who use open source technologies, we've got to keep on looking and seeing how can we repackage this, what we're doing, in a way that can make us use technologies that, or kind of ways of doing stuff that are now standard. I mean, S3 is now pretty much the standard way of doing object store, and tape is still very much the standard way of storing large amounts of data for long periods of time. So merging these two together seems like an obvious thing, and we thought, well, let's just give this a try. Let's see what we can do with Ceph, and the National Research Foundation, the South African Radio Astronomy Observatory, gave us a small amount of money to do a bit of research into this and try and figure out all our what our blockers were going to be in terms of developing this technology. I thought this would be quite fun. This is like, obviously you have a choice at what level in Ceph do you access the data. So it seemed quite cool. I mean, maybe we just do it at the S3 level. But the problem with it was that there was kind of like a infinite regression here. It's like, we like S3, we want to use Ceph for S3. We want Ceph to kind of act as this interface or this lay in between. So let's read the data out at the S3 level and write it into another Ceph. But then it's just turtles all the way down, because at some point you have to actually implement something that's going to be the interface. So it seemed more logical to move on to the next level, the LibRados level, which is which is kind of, we can talk to Ceph quite easily using lib. You can talk to a pool quite easily using LibRados. We did also look at like using BlueStore and kind of accessing sharded objects, because if you imagine writing to an EC pool, you have your objects sharded into M plus or K plus M, so eight objects. You write those into 8 different tapes, and you then basically you use erasure coding to kind of save on data space. But we thought this was too complicated. There were, I think, we very quickly put this aside because we thought there were issues with trying how you access your, how you fool Ceph into keeping Ceph happy. And it seemed natural logical to kind of do this at the Rados level, because we could write object in and out at the Rados level, and your deep scrubbing will still be happy because you've told Ceph what you're doing. So Ceph is not upset. However, you are upset at the S3 level, and so we had to stage these interventions as you have operations that come in. You need to know that when somebody tries to do a request on your S3, there's a chance that that data might not be there. Hopefully, this will become a bit more clear when I show you the demo. So just like a primer as to what kind of operations we can support. If you try and list your object, you will, using your favorite S3 client, you will happily go and you'll get your return, and that's because they look at the meta pool and the index pool. So basically, if you want to check that your data is as you think it is, and get some meta information about the data, that operation is absolutely fine. However, if you want to do a data read or write, things get a bit more tricky, because what we do is we look at the data pool and we say, cool, well, this is where we're going to start doing funky stuff. We're going to read data in and read data out. And there's a chance that when you have a read request come in, your data might not be there, because obviously it's now existing on tape. So here we got predefined states of data. We've got, and we've come up with our own terminology, but if data is backed up, it means that it exists in Ceph as well as in the tape. If it's archived, it's now only existing on tape. It no longer exists in your data pool. And then it's restored, which goes back to like a backup state, which is they exist in both, and you can access your data. So to kind of illustrate this a bit more, if you have your S3 object, that S3 object is broken down into a whole bunch of smaller Rados objects. If you want to figure out which Rados objects belong to your object, you just look at the X-atter on the head object of the head Rados object of that S3 object, and you decode that Rados object, and it'll tell you this is a map to which objects are in your object, which Rados objects in your object that need to now be manipulated. So what we do is we would we get a request coming in saying it wants to, so we want to archive this particular piece of data. We will then go and decode the manifest, and in fact, when we archive, all we do is we truncate the data. So one of the interesting things was instead of deleting the Rados objects, we thought we'll just truncate them to 0 size. And that's because we keep all the metadata that's attached to that object and all the attributes that attach to that object, which there are some on these tail objects. So hopefully, I've given you a vague idea about what we're doing. I'm now going to try and do a live demo. Okay, cool. So you see the screen is split into, I use Tmax. I don't know who uses Tmax, but it's like a really awesome tool. This is where I'm going to drive everything. So this is kind of like my testing screen. This is the screen I'm going to drop into our Ceph Docker container. And this here is just listing a directory. I'm running tree on a directory. That directory is, so we obviously, I'm running this all on my laptop, so we need to have Ceph contained in a single container. So we use something called Ceph Nano, and we tore it apart and repackaged it for ourselves to use. We can't obviously have a tape library attached to my, I can't bring a tape library to the conference with me, so we needed to have a fake tape library system, which we just use, we use a file system. So as a backup objects, we're going to see files being listed over here, and that will represent my tape library. As I push objects from S3, I use S3 command. You'll see objects appear in in Ceph. So I'm just going to turn here so I can see what's going on. So I should quickly run like that because I need to use sudo a fair number of times. Okay, that worked. Okay, so make init. So I just ran a whole bunch of make scripts to make this life easier for me. Okay, now I need to know that's a prompt to me to go over here, run make exec, and then watch -n1 Ceph df. Okay, cool. Okay, so you can see I'm now listing the pools that are existing on my Ceph cluster. And you can see here what I've done is I've gone and set up a S3 test user, and I've added some keys because extra pieces of software that I have to do the data management need keys to access the particular pools that we're interested in. As you can see, there's no data pool yet. There's no index pool, and that's because as soon as you try and now, because as you start Ceph, you don't. As you start Ceph, the pools aren't created. So now we need to. The standard behavior of Ceph is now to actually to go and create those. What? I'm making it. Oh, I've already done that one. Thank you. Make start. Okay, helps if I can spell. Okay, cool. So what I'm doing is I'm writing a single megabyte object into the bucket, and you can see the index pool's created. The bucket's been created. Now there's going to be a single one object that's 1 megabyte size. Cool. Okay, we've just put an object into. So the reason why I do this is before I start the rest of my software, I've got to make sure that these pools exist, because if they don't exist and I try and connect to them, the Python Ceph bindings just hang. So there's no test connect, and I haven't written a wrap around that to make sure that we can return from that. So it's just setting up. So now that I've set up everything on Ceph, it's busy building the rest of my containers. So now the magic happens, and I do make test. So what should happen here is that, okay, I've just written a 4 megabyte object in. There's one object, it's 4 megabytes in size. Okay, cool. Now what's going to happen is I've just written it out into my tapes, and now these are backed up onto tape, and the 4 megabytes should disappear at some point. So the object remains, so we still have one object, but the 4 so this is a bit laggy, so it takes a bit of a while to update, but hopefully at some point. Oh, here we go. Okay, cool. So object's still there, so it still exists. So you can, it's just like a placeholder for what was there, but there's no data left in there. I then write the data back in, and I do a quick test. I just download the data to make sure the checksums are the same, that everything looks fine. So everything looks fine. Now I write a 20 megabyte object in. And what you'll see is the non-EC pools created. That's for tracking metadata when you do multi-pod uploads. So this will be a multi-pod upload. We write to 2 tapes, so you can see 2 tapes have been loaded, and we've loaded all the data into the tapes. So these are all the Rados objects now that make up our 20 megabyte object. And you can see it's gone down to, it does tend to be a bit laggy, so it might not show it go down to 4 megabytes, but it should have gone down to 4 megabytes. We're now back to 24 megabytes. We've restored it, we've done a checksum. Okay, cool, everything's fine. And that's basically the magic that we use to read data in and out. So you can see now we're in the state where we've got our data's it's in Ceph here, it's sitting in the data pool. Our data's sitting on our fake tape drive, so our tape library system, sorry. So we've got, a requirement for this particular client is that they want to make sure that we have redundant copies because of the value of the data. So we write to 2 tapes. We can write to 3 tapes. You can write to a single tape. That's just a message that you pass in when you ask the tape library to back up the system. This is what you write in. What I also want to show is that we've started messing around with Lua scripting, and if I say make delete now, I get this message back telling me that I can't delete data. So I just try to go and delete the 20 megabyte object. It tells me I can't. So we're just using Lua scripting to refuse a delete. And this is kind of like us starting to build those interventions I was talking about to, when somebody does a standard S3 request, we need to manipulate in some way to make sure that when people try and do something they shouldn't do, it isn't allowed to do it. And that was great about being here is that we then started talking to the Rails Gateway guys, and they were like, no, they think Zipper is a much better project to look at in terms of the kind of things that we want to do. So so we've already paid for the conference because we've gathered all this useful information. So that's it. That's the end of my part of the talk. I'll now hand over to Martin. So I hope I've left you time, Martin. Bye-bye.
Well, I was actually really hoping you would run over time, then I didn't have to talk.
So just lost the screen.
No. So I'm going to chat to you guys about the implementation part.
Did I break it? No.
Okay. Yeah, so my concept of talking about implementation was bringing up the code and then doing a code walkthrough. But my wife informed me that's very antisocial. So I'll try and do it with slides. So I'll try my best. All right. So all the bits that Tom have showed you is not just one monolithic piece of code. We want to support having multiple tape drives. So we're using a big library. I'll talk about the library just now. And the library has multiple tape drives in it. So in our case, the library, the hardware we've purchased has got 10 drives. So we want to make sure that there's parallelism in that set. We have something called the Blue Data Manager. This is a Python process, and it sits on top of everything. It connects to Ceph. It talks to Rados. It talks to the RGW gateway, and it basically informs all of our components, which is the total blob store. And the blob store contains the tape library and all of the components that do the data movement. The Blue Data Manager itself does no data movement. All of the data movement is done in the total blob store. So this is basically where the heavy lifting is, but the Blue Data Manager is the brains of the operation. Like I promised, now we're jumping into the hardware. So first of all, the tape library we've decided to use a IBM TS4500 tape library. We are not beholden to the IBM tape library. We can actually use any tape library. There's a few APIs that's specific, but we should be able to use any library. We've chosen the IBM library because it's something we're familiar with. We've used it in other projects before, and it's an amazing piece of hardware from a mechatronics point of view. So we just kind of went with that. It's what we know, and we're very impressed with the actual hardware. It is a refurbished library for this project. We couldn't afford, or the whole project itself couldn't afford a brand new library, but we've used a refurbished library. Those familiar with IBM would say, but we should use the S55 because it's the higher density frame. We just couldn't get hold of those. So it's 4,600 slots, it's 5 frames, and it gives us like 82 petabytes of storage. In front of that, our Ceph cluster, I'm not going to read the hardware spec, but that is our planned hardware, or that's the hardware implementation. The nice thing is that by the time we get home, the hardware should be in Cape Town, we hope, if all shipping happened properly. And in 2 weeks from now, we will be going to the Karoo, or the desert, to do the implementation and the installation in the data center there. So, being very lazy, we've automated the installation of the whole stack. So that is the Ceph, it's our components, it's basically the whole setup. This is needed, one, because we do want to make sure we deliver a good product, so we do a lot of testing. We tear down the whole cluster. We don't want to leave parts of Ceph running or stuff. We tear down everything. So we've got a nuclear cleanup Ceph script that really, really takes everything down. And then from there, we deploy. Our deployment is Ceph ADM. And we've got a lightweight, very opinionated Ansible collection that we've written that sits around the Ceph ADM and basically just pokes it until there's a running cluster without any hand holding. That's very important for me because, like I said, I'm lazy and I want that cluster to be the same for each run. For us, it's open. I'm not sure it's kind of usable for everybody, but it's a really nice thing to demonstrate how cool Ceph ADM is. Okay, so the future. Okay, just want to leave some time for questions. We are still in the thick of it. We are still developing this product. All of our testing and experimentation show that it will work. And by the middle of this year, we'd want to have a functional, I don't want to call it a prototype anymore, a functional system, something that can start to be used. Fortunately for the client, for the radio astronomy, this would not be the only source of the data. There is another copy in Cape Town. This would just be the on-site copy. So in a way, it is their geo-redundancy. There isn't geo-redundancy at the moment. So when we implement this, and so we will have time to refine it and get it perfect. Yes, a couple of things. Like I said, we need to complete the deployment. At the moment, like Tom said, the science data is it's not exactly like your business use case for the data. It is immutable data. It gets written on the cluster, and the data itself never changes. But to take this product further, we would really like to look into S3 versioning, where we will archive onto tape different versions of the S3 objects. So when an object changes, that we can kind of archive that object. So at the moment, we cannot afford to allow somebody to change an object, because then we will have to track that and fetch it from tape and, flag it as old and stuff like that. It's just too complicated. We would also like to support multiple pools. At this stage, we can only work with one data pool in RGW. It's kind of not an architectural limitation. It's just we haven't got to looking at reading more than one pool. So we just kind of use LibRadars to connect to one pool and only service that pool. Yeah, and then, one has to start thinking wild ideas. If this works well for S3, would it make sense to try and do something as crazy as fiddling with the LibRadars objects under CephFS? That's probably more a question for a couple of beers, but those would be kind of things that we would like to kind of look at and think about. There's a lot of challenges still for us and a lot of open questions. I think the ones we list here, the ones we're willing to talk about, they are still like ones that we haven't percolated and probably solidified yet. But it's kind of, in our testing, we can only simulate and test up to a certain scale with our test rigs. But what will happen if we have billions and billions of objects and we do truncate them and they're empty, and then we suddenly fill them up because there's a query for a certain observation or data set to be read from tape, and that whole process is an unknown, and that is something we can only test properly at scale once we have all of the parts available to us. And that feeds into the management of your cache layer, which is pretty much a normal caching problem, but managing that and keeping track of it. We, just to say, for these things, we are going crazy with making metrics and logging that into Prometheus so we can track everything. Each of our sub-processes, the Blue Data Manager and the Taller Blob Store and all of its workers, all have Prometheus endpoints, and we're just like pushing metrics to that. Probably way too much at this stage, but we'll kind of monitor that and kind of use that to make kind of informed decisions later on. Yeah, and then like Tom has already said, like, have we missed anything? And yeah, what was really exciting as well, it has been a few people who's come up to us and started talking about tape. I was really not expecting that. I was expecting that we would be the only nutcase who wants to talk about tape libraries. But there's been a lot of interest. And so from our point, we'd really like to speak to you guys more about tape and see what's the interest in that. Thank you very much.
So yeah, there's sorry, on the last page, just said I'd give our contact details on the website. So yeah, are there? So we've got. I think we do have some time for questions. We should have, yeah, because I think we had a 45-minute slot and it's 3 o'clock, so we've got 15 minutes. So yeah, if there are there any questions or comments?
Hi, thank you. That was very interesting. I was in all of this system. You keep so all the data you need for the retrieval from tape, or also you are still store everything is still stored on the Ceph cluster. So you don't need any external entity.
No. So that means that when a request comes in to read an object that has been archived, we just look at the Redis Gateway manifest. We say this is a list of objects that need to be restored. We then send a request to the what we call the Taller Blob Store, which is the shim that sits in front of the tape library, that then goes and figures out which tapes need to be retrieved, where the object is on the tape, and retrieve those objects, and then put them back into the
So you put it back into Librados, and then you change the size of what you were picking up from the index.
Well, no, we don't change anything because Ceph doesn't. I mean, S3, the S3 Redis Gateway doesn't know that we've done this. So we will only allow the Redis Gateway to do a read once the objects have been filled. So we don't. We don't have to tell anyone anything at the kind of the because as long as the objects are there, the S3 request will go and do exactly what we did, which is look at the Redis, look at the manifest, and then say, oh, I must read out these objects. We'll read out those objects, and your S3 client will just read them out and put it all together, and you've got your object on your client.
Thank you.
Just to add to that, there is a piece of data that we have to keep separate, and that is to know on which tape which blob lives. And for that, we use a Postgres database inside the blob store. And we have some crazy ideas of making Ceph store that, so we don't even need this database. But for now, it was just the easiest thing to do, is to have this database. And then to say is, as we store all of these blobs into onto tape, we also store the metadata. So kind of what is in Ceph, what's in the database, along with these blobs. Because you can think the blobs, it's quite a big chunk, but then metadata is just like, not even a K, it's like a few bytes compressed. So in theory, we can actually recover the whole system if we read back from tape. It'll be an absolute pain to do, but it gives us that security that, in case of emergency, we can read everything back and rebuild the whole cluster that way.
Hi, 2 questions. The first one, is this the Toslo software meant to be integrated in a Ceph cluster, which already is there and operating with OSD disks, etc., or is meant to be purely a standalone component which does the gateway work?
At this stage, our plan is to just have a standalone cluster, but there's no reason why it couldn't be a production cluster and we interface with it. I think at the moment we're just a bit scared that you take the production cluster and you go fiddle with like a pool there, but in theory, we're using standard library, standard calls, libRados, into the pool that RGW uses for data only. So it could be a full-on working cluster.
Thank you.
But I think if I can just add to that is we don't quite know how much we want to put in the Rados Gateway yet. And at the moment, we've built what's called the Blue Data Manager. And it looks like after speaking to the Rados Gateway guys, there's actually quite a fair bit of what we're doing there, which could probably exist in the actual Rados Gateway. So with, connecting to some other bits of information that we need to be able to inform that layer. So that's like using something like Zipper as a way to and there was D4N as well. I mean, I still need to go read up all about this, but basically what this then means is that if we can start figuring out how to include this all in the Rados Gateway, it means that we could find other teams that are interested in doing similar stuff, and we could at least come up with some standard way of at least doing the interventions at the Rados Gateway layer, so that we can be implementation specific depending on who we are and what we want to do, but we can do it in a standard way, so that obviously that community is always better, right? But it'd be good to kind of and so as I say, I think we'll hopefully have a few more talks as we go along to try and see how we can better integrate this into because as I say, I think what would be nice is if you can get an S3 request coming in, and you as the user don't know that using CyberDuck or whatever, when you access your data, that there's you can still use your standard tools to access your data. Basically, what I'm trying to say is maybe, and that all sits behind, well, as much as possible sits behind the Rados Gateway, so that you don't have to interact with another API to kind of figure out what's going on with your data, or how to access your data. Yeah.
Thank you. And the second question was: are you using LTFS, or you have your own tape format when you write?
So what's the question?
Are you using LTFS?
No, we're not using LTFS. No, we will tar, but we've got we're not even tarring anymore. That's right. Oh, goodness. Yeah, we're just writing directly on it. Please answer the question.
As I've mentioned, we're lazy. We take the Rados objects and we just write them to tape, and we remember the position in the tape, and then we have a little fixed size blob that we put in front of them with like a little bit of metadata and a couple of zeros, and we realized that if a tape is 18 terabytes big and your blobs are big and this metadata is so tiny that putting too much effort in just has no value. So we just have this little slot where we know how big it is, we know what the position is of each blob, and that's what we do. And so when we then approach it on the tape side, it is just right. And it's surprisingly fast, and it's very simple. So we have no magic format. It is just Rados blobs to tape. Yeah. One minute.
Thanks. I have a follow-up just on this, because I think if I write a large object into your system, this will result in a number of writes to tape, right? Are you able to exploit the full bandwidth of a tape system like this, which you would hope to be able to write at like even 400 megabytes a second, something like this? Do you manage that?
We think so. We'll have to see at scale. The other thing, I mean, we're running out of time now. The other thing is also, we don't expect to just have one of those big objects arriving at a moment in time. There's 24 imaging nodes, and they will all send data when they're ready. So that is why there's this NVMe cache layer. So the Ceph will receive at a massive rate the data, and it'll all come in like suddenly. And the faster we can kind of absorb that, the faster they can continue with the next observation, because they're literally waiting. The telescope's waiting for the data to get out of the way. Once it is actually on the NVMe, we've got quite a bit of time before the next tsunami of data arrives. But so at that moment in time, we have lots of S3 objects, and all of those S3 objects are broken up into lots of Rados blobs, and we'll basically just service them all. So there should be enough work for a tape drive to do to just stream the data. See if I don't introduce a bug.
Yeah, so just to carry on with that, and this is where kind of, we know the client, we know what kind of data we're getting, and we're not getting big Ceph, we're not getting big S3 objects. A typical data run is broken down into NumPy arrays. Each NumPy array is about 20 megabytes. So we kind of know the size of the data coming in, and it's lots and lots of smallish objects, not one giant object. Or that isn't the use case that we're trying to solve here. And yeah, but once again, if we can, we are trying to put the protocols in place so that we can, manage something like that, and hopefully do it, as Martin says, optimally. But yeah, that's not really our current use case. Yeah.
Thanks.
Great. Thank you very much. Sorry.